USDA logo, United States Department of Agriculture.
Hello, today is Wednesday, March 16, 2022, and I am interviewing Dr. Penelope Perkins Veazey, Professor of Horticultural Science at North Carolina State University and at the Plants for Human Health Institute. We are on Zoom today. I am Amy Morgan. I'm an archivist in special collections at the National Agricultural Library. I have the honor of interviewing Dr. Perkins Veazey because she is the 2021 winner of the B.Y. Morrison Lecture Award. The United States Department of Agriculture, Agricultural Research Service established the award in 1968 to honor Benjamin Y. Morrison, a pioneer in horticulture, and to recognize scientists who have made outstanding contributions to horticulture and other environmental sciences. Welcome, Dr. Perkins Veazey. Please start with stating your name and spelling it for us.
Hi, I'm Penelope Perkins Veazey. Spelling it?
Please.
Oh, okay, sure. Penelope, and last name is Perkins, Perkins hyphen V as in Victor, Eazie.
Thank you. Now, please share some biographical information and begin as early in your life as you like.
Okay, so I grew up in New England, specifically in Western Maine, in a very small town of about 500 people. And it was primarily a farming community. And we did not have a farm. We had an acre or so, but I have 4 siblings, so we were a fairly large family. So part of our job was to make ends meet, was to grow vegetables. And of course, that was my least favorite job. I preferred to grow the flowers. At that time, there wasn't much use for flowers other than decoration, but there were many times when I was walking down the row of beans, I swore I would never do this when I grew up. But in the end, when it was time to go, my mom was always big about education. You know, you will go to college, even though we didn't have any money and we couldn't figure out how. But when the time came, she's like, okay, you apply, you go, we figure out what happens next. So I said, but what am I going to study? She says, well, pretty clearly you love plants. So of course you'll study plants. And I was like, oh, okay, that makes sense. You know, 4-H is a big part of our time growing up as well. So that taught me a lot of interesting skills and communication. So went to the University of Maine at Orono. And this time, of course, this was in the period that education was for people who were on the poverty level, you could get enough to get by. So that was great. It gave us opportunities to go to a state-run school. And we still had some investment, but it made it possible, which I bring up because today is not always the case. And then after I got done with 4 years at the university, I went, now what am I going to do? I have a degree in plant and soil science. And this was during the Rust Belt years. This would have been the late 70s, early 80s. What am I going to do? New England is in a total turmoil. There's no jobs. What do I do with a degree in plants? I can go water plants in Boston, or I can work in a greenhouse somewhere and make minimum wage. And somebody in my department said, have you ever heard of graduate school? And I was like, what's that? so I said, well, okay, let me apply. So I applied to Southern schools because this was also the year of the Great Winter. And I was living in a trailer where the pillows literally froze to the wall every night. So I said, okay, I want to go south. And so I applied it to Florida and applied to North Carolina. Florida took me, moved down to Florida. I'd never been there in my life. We moved in June and I had never been so hot in my life. So it was an interesting period of contrast. But what was eye-opening was, you know, Florida compared to Maine in terms of agriculture is hugely different. Maine is blueberry acreage in the east, apples in the west, but a little bit, and potatoes in the north, but not anything like the scale of Florida. And the other thing was striking to me coming from the Western Mountains was how flat Florida was. So those are my 2 eye-opening moments there. And I learned so much about how to do agriculture and, you know, what went into real serious horticulture. That was the other thing. Horticulture was valued. It wasn't just potatoes or, you know, a little bit of this or that. So it was great stayed at the university there. I did my master's was in production, and then my department chair or my advisor became department chair. So I had been talking to a guy who did post-harvest and ended up over in post-harvest, which turned out to be a much better fit for me. And so after I worked on strawberries, and what I found striking about the strawberry research, and I didn't put it together till many years later, but I like crops that change color. I really enjoyed color. And I was working on some ethylene work in strawberries. And then, of course, what happens? Get done, time for another recession. Where do you get a job? So it's like, yeah, universities were slacking back on hiring, and even postdocs were scarce for horticulture students. And USDA had an opportunity in Lane, which is very remote, southern part of Oklahoma. And it's very hard to fill these types of positions because most people have never been in a really isolated area in their lives, and tend to not last very long there. It's like, well, I'm from Maine. I grew up in a small town. I think I can adapt. So I moved out there and spent the next 20 years working on various crops at the station there. And one of the things that happened there was kind of a long-term process that happened, but when you work for a USDA ARS, the idea is you form national collaborations, which I thought was very interesting coming from a state system and a university. So I ended up, first of all, going next door to Arkansas. It turns out there's a breeding program there on berries in rubus, specifically blackberries. And it had been run by Jim Werr for many years, and John Clark had been working there as well. He's now a professor at Arkansas. And as he asked me if there was something that I could do for him on post-harvest, I was like, sure, let's start. And that turned into a very fruitful relationship, kind of a pun. And it ended up, the blackberry industry greatly took off at that point. They had the breeding genetics, and I was providing the shelf life and storage and some of the physiology and what was making the blackberries last longer. And by having them last longer, it started the industry at the local level, and then the national level, and then the international level, because Mexico became a player and was able to provide blackberries during the winter months. And some people would look at this as a competition, but actually it helps stabilize shelf space in the store. You want to make sure you have something on the shelf as much of the year as possible. Otherwise, the stores will drop their product and go on to something else. I'm going to take a break right now. Okay. Now, going back to color. So, so one of the things, I love small fruits. I love working with small fruits, and strawberries were not much grown in Oklahoma. So blackberries became my new small fruit of choice. Spent many years working on them. But then our station was a cooperative event between USDA and Oklahoma State. Well, the Oklahoma State side decided that they would focus their efforts on cucurbits, specifically on watermelon. And I had done some work on watermelon there, where watermelon grows quite well in that area. It's treated almost as a dryland crop. And we had done a little bit of work on this. And so we're, okay, that's great. We can work together on watermelon. We did some work. Then the Watermelon Promotion Board decided that they had noticed with alarm that the United States was showing a loss in people consuming watermelon. And they decided that they would put out a grant application and see what they could get for people to come up with new ideas on watermelon that might help with consumption. And so we had been working on the redness, again, the color, and we knew that watermelon had lycopene in it. Lycopene's a red pigment that's associated with tomato. So I said, well, okay, let me just go ahead and write a grant. And we got collaborators from the university and as well as the station. And the Watermelon Board was blown away by this. They had no idea that watermelon had anything in it that was good for you. And it had been just regarded as kind of a source of sugars. So we ended up doing some work on the lycopene part for the next 3 or 4 years, looking at varieties, looking at changes during storage life. And then they were like, okay, what else is good in watermelon? What else can we use to sell watermelon? And so we started looking around some more. And there's an amino acid that's unique to watermelon called citrulline. And it turned out that lycopene is really good as an antioxidant. It will it will basically detoxify radicals, free radicals in your body. And it seems to help also now, fast forwarding with all the years of research since then, that they're looking back now, it seems to have a lot of other effects that we didn't know about at the time, such as eye health. That one's fairly new. But they wanted, when you work with a commodity board, they're always about keeping their product in the news in a good way. And so they wanted, okay, what else is in watermelon? We went to citrulline, said, well, citrulline is an amino acid, but it's used to protect the nitrogen source in watermelon during droughts. So there's a strong physiological reason for citrulline to be there, but what will it do for humans? And when we started digging around in literature, we found out that arginine is used for people with heart problems and circulation problems. And citrulline is part of that nitric oxide system. Citrulline generates to arginine, arginine to ornithine, and back to citrulline. So it's a constant system. And there was some interest at that time as well that citrulline might be a better product to give to heart patients because their tolerance was better for it than it was for arginine. So we started working on citrulline and found out that we still debate about this. Where is citrulline most located? I say it's in the flesh. Other people say in the rind. It could be both. It could be how you extract and whether it's a dry weight or fresh weight basis. But we were able to take that work and start generating interest in health studies with that between the two things, the lycopene and the citrulline. So other people started becoming involved in this. This would be the people who are started sports medicine people, number one, nutritionists, number two, and then suddenly the health people have kind of moved in on it as well. They're looking for alternate uses. So the end product of all this, we spent probably about 15 years on watermelon, was in the end, we know that it's good for blood pressure. It will lower, just consuming watermelon will help lower blood pressure. Great hydrator, seems to have some effects on blood pressure, also on circulation, and now possibly eye health issues may help with cataract prevention and the lycopene part. And then the other spinoffs that came from all this were the products. Once you get something in the news a lot, people start getting a lot more innovative. And they say, okay, the US is really big on just eating fresh watermelon. Other countries have made products like watermelon juice forever, but we haven't. So suddenly watermelon water started appearing, which is really tiny amounts of watermelon, a lot of water, and some other products like I saw one for dehydrated watermelon chips, which I think would be interesting to eat. And then there's some other products now. A lot of people now trying to make pharmaceutical products with the rind itself or extract the citrulline and make it for the rind. So it's been a very interesting journey for me to go from very basic, obvious horticulture work into things that are springboarded into, people being very interested in health properties for what I've worked on and see how those collaborations start spinning into bigger circles outside the country and into other disciplinary fields.
Well, thank you. Now, you mentioned this. Your research focus is post-harvest methods and storage technologies for fresh fruits and vegetables, and assessment and screening methods of bioactive compounds in fresh produce. So why did you choose this specific field in horticulture versus a different field in horticulture?
Well, some of it is just where you are at the time. And I knew that I was much more interested in post-harvest aspects than I was in production after dealing with both sides of it. And at the time, when you're job searching, post-harvest was a little bit easier to find positions for. And I think for me too, the other thing is growing up when you don't have much money, you really don't want to waste. And so being able to do an aspect that was directly related to reducing food loss was very appealing to me. The bioactive compounds came about a little bit later. because there's lots of things in post-harvest, like post-harvest storage. Yeah, that was great. You can demonstrate that you can get different ways to calculate how things last, or how long can you keep blackberries, how can you extend their shelf life. But the other side of it was, okay, the phytochemicals was fascinating to me. To find out that there were things in fruits and vegetables that could act as pharmaceutical products or replace pharmaceutical products was just thrilling. And it was just a whole new day. I had no idea that this was back in, all of this happened in the late 90s. And this was after the 1995 research was published that said that we were ignoring fruits and vegetables and we needed to start consuming more because of the phytochemicals. And it just unleashed a whole bunch of work. And looking at blackberries and looking at what was in blackberries, and then especially watermelon, really digging into watermelon, taking it apart. It's one of those things that you go, this is where I need to be. And when a position came up at North Carolina State, they were opening the Plants for Human Health Institute, which was a new idea entirely. And it was such a strong fit because it required both post-harvest knowledge and phytochemical research. And it's like, wow, this is my chance to expand my horizons and go back to the East Coast and work with other people who are of like minds to me, and really get together and do some interesting work.
Wonderful. Now, the next question has to do with watermelon, but you touched a great deal on that. Is there anything else you want to add about what drew you to this fruit besides color or the process that you went through with watermelon, or do you feel like we've covered that?
Yeah, I think I got ahead of myself on that. But yeah, basically, I find that I enjoy, if there's a crop I like, I'm much more enthusiastic about working on it, and I'm sure that's true of everybody. But yeah, we sample so many watermelons. We get to be real sophisticated tasters of watermelon, and that made it a lot more fun. And watermelon's incredibly challenging because if you go to the field, it's still so primitive in how it's harvested. It's, you walk out to a field, it's grown in the field. It's not grown on trellises like it would be in some countries, but it's grown in the field on the soil, maybe on the plastic. You literally have to walk through the field. Somebody selects what's ripe and what's not. There's no signals to say, hey, I'm ripe. And then you toss it onto the back of a school bus and you take it to a pack shed and then it's crated up. That's it. It's amazingly primitive to me when I look at how sophisticated the work on small fruits is. Mm-hmm. So that's a kind of a fascinating idea that maybe there's more to be done on the harvest and handling side as well at some point, and figure out how can we run our fruit through some sort of scanning system to see how much sugar is in them without it being destructive, for instance. Would we get a premium for that? Is there a way, is there somebody out there in the breeding world who can develop a way to tell when a watermelon is ripe? We still haven't got that place yet. Or can we make a watermelon that's the size of an egg so we can carry it with us in our lunchbox or to work? So there's lots of cool stuff about that I'm still interested in.
That's fascinating. I never realized so much went into watermelon, and it is one of my favorite fruits. So, so to move on to blackberries, can you describe your research more in depth and the results of it?
Sure. So with blackberries, we started out by a simple question. So the breeder, John Clark, would say, hey, their charge at the time was to take blackberries from basically a wild size, which is tiny, and make it a large size, so that they were using tetraploid to increase the size. They had to have winter resistance, so they wouldn't, the buds wouldn't be killed in the cold, because they have Oklahoma, Arkansas tend to have spikes in the weather. They drop really rapidly. They go up really rapidly in temperature, and this can cause a lot of winter damage, productivity, and then of course diseases as usual. But so they get to the fruit stage, and they were using background material that some of it came from Texas, and some of it seemed to be firmer than usual. So they're interested in, okay, can we increase the firmness? So because blackberries, if you pick a wild blackberry, it's sort of like a wild strawberry, it kind of dissolves in your fingers. And so any improvement is a good thing. This would be at the beginning of the linear phase of a curve. So they did the selections. They came up with some really good material, but going out, what they realized when they went out to the field and tested it, it felt firm. They put it. They would always put it in a clamshell or a punnet, bring it into the lab, let it sit overnight, and test it again. It would soften. Why? So we went over and started harvesting, and the first thing is to look at comparisons to see if we could pick out firm versus soft, and we could. And the next question is why. So we started digging into some of the physiology of it, and it wasn't a clear picture. It was, at that time, there was ethylene being produced, and ethylene is a big softener in a lot of fruits. It's a hormone. But there wasn't a clear picture that the softer varieties had more ethylene production than the firmer ones. Now, looking back on it, I think it's probably more to do with some of the softening enzymes that are activated with certain genetics more than others. But it was really interesting to go through the fields and sample. And then we came across one that was so hard. It was so tough. It tasted fine, but it was almost what I would call a crunchy blackberry. And then we would bring it back and use that one. It would never soften. And I used to call that the blackberry you could throw against the wall and it wouldn't have any juice. And we never had the ability to really dig into that at Lane to figure out what it was that was causing that. But I've often figured that looking back, it would be fun to do that, and maybe the new breeder will do such a thing. But basically, we were looking at that time for physiology. We were looking at color change. We were looking at respiration. We were looking at ethylene to see if we could find differences. And mostly, though, it was phenotypic type responses to storage and figuring out what was going on. So that was very helpful to them. And it was a springboard to get the industry up and going, to be able to transport fruit and have it sit for a week in a grocery store without melting down and turning fuzzy.
So now we're going to talk about your work with students. You're very active with mentoring and training graduate students and future horticulturalists. What are some of your most rewarding experiences in this area?
Okay, so that one I had to think about a bit. So I think first I have to say that when I was in Oklahoma, the thing I noticed a lot in this time period, which would have been the 90s, women weren't given much of a shake. And so when I came there, most everybody that had a job during the summer was male. My first thought was, okay, whenever possible, if there are young women that are looking for jobs, I want to give them a shot. So that's what I did. And part of the fun part, and this was long before grad students, we didn't have graduate students in Lane. But I bring this up for a reason, because some of those people, they weren't necessarily going to go into horticulture. One of them became a pharmacist. One of them became a teacher. They went on to other jobs that weren't necessarily in horticulture. But the point was, they were able to see what it was like to work in a laboratory, what it was like to work as a professional. And it gave them some inkling that there was something to do other than the very minimal jobs that were available there. So I came to North Carolina. I was amazed at how many grad students they had. Oklahoma, you were lucky to get 2 a year in the whole department. So it was wonderful to be involved suddenly in grad students because they're so enthusiastic and everything's so fresh. And so it's fun to mentor them just in general, to have them understand the whole world of science to start with, and how you approach doing scientific trials. But I have to say, when I was looking back through some of these, it's always fun when they win a competition. That's great. And because, you've got them so their communication skills are great and they know how to say what they're working on. But I came across a paper that my grad student had, she's my third PhD student. No, she was my first one. She had gone to a postdoc and then was working for a company. And the other day I happened to find her paper that she had written as a postdoc. And I went, wow, this is so great. She's made so many changes. She's grown up. And that's what you like to see. It's like, okay, this person is now a mature scientist themselves, and they're making a difference.
Definitely. So you are very collaborative in nature. So what have you learned that was unexpected while collaborating with others?
Oh man. Yeah. So many weird things happen there. So you get outside your comfort zone real fast. You're in horticulture. You all know what a cultivar is. You know the terminology. So the first thing that happened when we got collaborative was with food science people who, at that time, when you said the word variety, had no idea what you were talking about. Food is food. Who knew there were 400 kinds of watermelon? Who cares? So that was the first interesting thing that happened. So that was my first clue that not everybody talks the same language. And then we got involved with some other stuff. I was doing we were interested in working with, I forget how we got into this one. There's a guy who was working on herbicide tolerance, and we had to do an assay for him on some sort of oats. It was a monocot. So that was a new experience too, because I went, wow, herbicide physiology and chemistry is so incredibly tough and intricate. And again, I had no idea that this was like this. And then we ended up here. We were working with a vast number of people there let's say vast, outside of horticulture, trying to support some of the smaller schools. I was working with one guy, I never did answer the question. We were trying to figure out why oak leaves did certain things. And I didn't have enough knowledge to answer that question for him. But when I came to NC State, one of the weirdest things I ever got involved in was algae. And it was a project that when I described Plants for Human Health Institute, it is the building that NC State owns, and it's made up primarily of people from NC State. But the next building over, this whole campus is composed of 8 universities. And most of these are, unlike the University of North Carolina and NC State, have about 12 scientists each. But there are smaller universities here that might only have 1 or 2 projects. So one of the smaller universities said, hey, I think I can make a vaccine out of algae. Are you interested in growing it for us? So what do I know about algae? Nothing. So we learned, and it turned out to be a fascinating project. Unfortunately, he could never get the vaccine part to work, but we learned a lot about what not to do and what to do, and how growing algae is its own interesting specialty, put it that way. And it's a big deal. It's a big business. But bioenergy, obviously, that's number one. But there's also some algae that's used for pharmaceutical products. So that was probably the weirdest one I've worked on in my whole life for that. But most of my collaborations, sometimes people say, hey, we're growing stuff under lights, and we need somebody who understands what might be going on at the physiological level. When you start using red and blue lights or green lights, what might be changing? What can you predict might be changing? And how can you help the student figure out how to assay for that? Some of them have to do with production work. Probably the most fun one I ever did was with pumpkins. And there's a very simple question that pumpkins have about 2,000 acres in North Carolina, actually fairly large for the United States. But the handles, which are the stems, would fall off. Why? So we looked into that, and that was a great deal of fun. So, because the most fun part of this project, this is kind of like a discovery part, which scientists don't get to do much. Usually you're having these methods are worked out. How much force does it take to remove a pumpkin stem? And it turns out between 30 and 100 pounds. So that sort of stuff is really fun. And so these collaborations turn out to be all kinds of interest. They can be very time consuming, and I think the worst one we had was peonies. We were working with flowers with somebody. He was trying to extract some chemicals from peonies to find out why they were lasting or not lasting at cold storage. That one was intense. So we try and marry our skill sets in the lab here and their interests with especially with what students might need is for the department, because not, they're having to look around and find out, who can do what to help them with their PhDs or master's thesis. And some of them are driven by, okay, we have, a block grant, but we don't know anything about how to store pumpkins and what to look for. So, it's just, for me, it's fun to do all this stuff, trying to figure out new things, keeps me stimulated.
Very interesting. Now, you've touched on some programs and projects that taught you something you didn't expect. Is there one that stands out to you, or is there another one you want to talk about?
Yeah, I think about this one. Butternut squash is the one that comes to mind. So I come from, working 30 years with small fruits. So when you look at a small fruit, they never get better. They only get worse. And it usually takes a few days and you're never going to retrieve them back. So we had a study looking at butternut squash, which is another big seller in North Carolina, and had not worked with that particular cucurbit before. And I was fascinated by it because it got better after storage instead of worse. And that's the first for me. So it turns out with butternut, you harvest it when the flesh is still heavy in starch. And what was happening is if you let it sit in post-harvest, or basically store, a lot of people do this. They'll put it in their back bedroom or something like that, or the cellar. And over about a month, the color changes and it gets sweeter. And I thought that was fascinating because I had not been working with crops like that. I don't normally work with climatic crops to start with, and I certainly don't work with long-lived crops. So that to me was just fascinating because I could see that, okay, post-harvest mantra is you can never improve a crop from the time of harvest. Well, butternut to me was an exception. It got better. It's like, wow, it's sweeter. It's got more vitamin A in it. This is great. So to me, that would be the one that stands out.
Interesting. So we're about at the end of our interview. Is there anything else you want to talk about or discuss?
Oh, I would just like to say that it's been an interesting journey. Starting out in rural Maine and growing up and not having a clue about the rest of the world to getting to see the rest of the world and understand how other people do things. And then I think probably more importantly at this stage of my career is making sure that I pass that on to people, especially students, where you are in the world. And this is how you think at the 50,000 foot level, and, both for your project and to expand it to a global level. And I think that there's probably, I thought for a while post-harvest was kind of dying out, but with the food security issues and food losses and COVID, it's suddenly become of high importance again, which, personally is kind of interesting and gratifying to see that post-harvest isn't necessarily going to become the dinosaur I thought it might happen. So that's really about it, I think, to me, that there's hope in the world. The students are great. They'll carry on.
Yes. Well, thank you, Dr. Perkins-Veazey, for your time and for your body of work. It's just very interesting. And congratulations on your award.
Well, great. Thank you very much.
Thank you.
USDA is an equal opportunity provider, employer, and lender.